Right, back at it again with another leak coding attempt. So we're doing depth first search. Let's see which one we do and minimize myself here. Randomized, and we're doing the next closest medium. So let's see here. Next, the maze. Oops, I forgot to make myself float on top. Where am I? Here I am. So view, float on top, and we said we were doing the maze. Let's go. Never mind. I guess we're not doing the maze. Randomize again. Here. Whoops. Okay. Keys and rooms. There we go. This one works. Cool. All right. Problem 841, keys and rooms. There are in rooms labeled 0 to n minus 1, and all the rooms are locked except for room 0. Okay? Your goal is to visit all rooms. However, you cannot enter a locked room without having a key. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, denoting which room it unlocks, and you can take all of them with you to unlock the other rooms. Given an array rooms where rooms of I is the set of keys that you can obtain if you've visited room I, return true if you can visit all the rooms or false otherwise. Okay, so before I go and look at the examples, I'm trying to conceptualize what the problem actually is talking about. So we have in rooms, so there's like, let's just say 10 rooms. Okay, so now the first room, I can't, all of the rooms except for the first room is locked. So I can't enter 1 through 9, whereas I can enter room 0. Okay, so I enter room 0, and then I get keys, which are inside of room 0. So I visit room 0, get the key inside of room 0, and now these keys have other doors that I can now enter into. So maybe I have room or keys to room 2 and 4. So then I go to room 4. Maybe room 4 has 0 keys. Then I go to room 2 because I also have room 2's keys. Then room 2 has room 3's keys. So then I go visit room 3, but room 3 also has no keys. Therefore, I'm all out of keys. I can't enter all the rooms. Okay. So, example number 1. There are, okay, so there's 1 room, 2 room, 3 room, 4 rooms. And the first room has room 1's key. So does that mean that I can go into this index right here? Okay. So we visit room 0 and pick up key 1. Yes. We then visit room 1 and pick up key 0 or key 2. Yes. We visit room 2, okay, and pick up key 3. Yes. We then visit room 3. Yes. Since we are able to visit every room, we return true. Okay. So here, okay, cool. Here's the example of when one room has multiple keys. So like in this one, we get key to room 0, but that doesn't actually matter because we always have access to room 0 anyways. Okay. Trying to think about how a depth first search would apply to this problem at all. Okay, you are given in rooms so possibly I need to think about this problem in terms of no, a room is a node, maybe. Okay, so now here's the thing. I'm trying to think about how, because normally when you get a LeetCode problem and it's something to do with graphs, okay, you're like, yeah, this is a tree. And your brain automatically, like, bam, this is depth first search, or I should at least be thinking about depth first search or breadth first search or something like this, right? This, this, nothing in my brain triggers that this should be depth first search. Nothing in my brain even triggers that this should be anything to do with graphs. So interesting. But anyways, so def traverse, and the only reason why I'm doing this node, this is just out of like muscle memory. Okay, I know depth first search, I need a traverse function, but how am I going to apply recursion to this? If anything, wouldn't this be like a breadth first search? Because I can do, I don't know, while keys, like this, and then I can do keys equals an empty list, and then I can do what? So I do keys dot append, and then I want to append rooms of 0, so I get the elements inside of room 0. Okay. And then I also need some method by which I am able to keep track of if all the rooms were visited. How am I going to do that? Okay, this is definitely a strange problem because, again, there's no indication that it's a graph. There's no, like, next pointer or where you have a node that has two children, and so you can just recurse, like, left and right and add your base case. And then how am I going to keep track of if each room was hit or not? Okay. Well, let me just try to get the logic of going to each room, maybe. And then see if something like pops out at me. So, well, while keys, okay, then what do I want to do? So key equals keys dot pop. I think this is the correct. I think you can use pop on a list. I'm not exactly sure. We'll figure out if we get like an error or something. So keys dot append. No, we cannot do that. So the reason that I can't just do keys dot append is because let's say we have this situation here where 0 is part of the keys in room 1. So I get this value here, okay? And then I'm going to try to visit this room again. So I visited this room, then room 0 has key 1, and then I try to visit key or room 1, so I get this all of those keys again. So I need some way again to make sure that I don't what if I do something like this? What if I have like a set? Are can you like add and remove values from sets, or are they like immutable? That's something I should probably know, but I don't. Because what I'm thinking about doing, and this would actually solve two problems that I'm having. Number one, it would allow me to do some kind of like blocking here. So if I get a key to a room that I've already been to, I don't revisit that room and try to add all of those keys to a room that I've already seen. And number two, the second problem that it would solve is that I would have some way to determine like if I've seen all the rooms or not. So what I'm thinking about doing is something like this, where I do, I don't know, not visited equals, and it's going to be a list, and this list is going to be what is the syntax? Rooms of I for I in range length no, I don't want the value inside the room. I want just the room number. Okay, so I'm trying to create a list that has essentially, like for this one, it would be a list that has 1 or 0, 1, 2, 3, and then I'm just going to like take it away each time, or take, let's say that I do this one here, and then once I visit this room, I'm going to take 0 away, and then I'm going to go to room 1, and then I'm going to take room 1 away from this list. So I can do something like if key in not visited. Okay, so if this room, this number 1, is one of the rooms which I have not visited, then I want to kind of process it. So what do I want to do? I first want to take that room away. So not visited dot remove. I don't know if I can. I'm just making stuff up right now. Key. I think that this also has a problem where if I do like key in and then a list, this is a O of N operation, whereas I probably, for time efficiency, should use like a dictionary or something. But right now I'm just trying to get functionality, and then we'll see about the improvements. Okay, so remove. Okay, so I removed that value. Now I want to do what? I want to get those keys in that room that I have not visited yet. So keys dot append rooms of key. Okay. Now, if I have visited the room, I want to just go up and pop the next key. And I want to keep doing that until keys are all gone. And given a finite list of rooms, I believe this is guaranteed to end because I'm let's see, I'm always removing a room, so I'm not going to revisit a room that I've already visited. Okay. And then from here I can do return and then not visited. So if there is a value in not visited, then I want to return false. And if not visited is 0, like nothing is in not visited, I want to return true. So I just use that not to flip it around. Should we run it? How many errors do you think we're going to get? There's a pop quiz. If you're good at Python and all of these little functions, like is pop, is that going to work? Yes or no? What do you think? Is remove, is that going to work for a list? Yes or no? And then we're going to change it. We're going to see, first we're going to see if this even compiles. I don't think it will. I'm not confident about those two. But then once we get that, we're going to see if the functionality works. Okay, after the functionality, then optimization. I think I need to change this to be like a dictionary or something like that to be more optimal. So let's run it. Let's see. Okay. Oh, well, wasn't expecting. Oh, well, that's obvious, but that one does not count. That was just a little. No compilation errors. Let's go. I got the wrong answer, but let's go. Okay, what? Return false, expected true. Should we walk through a test case or should we use our favorite debugging tool, print? I'm going to try to walk through a test case, and then if that doesn't work, we're going to print. We're going to print. Okay, so 1, 2, 3. I come here and I get 1, right? So now 1 is part of keys. Okay? And then not visited should have 1, 2, or it should have 0, 1, 2, 3 in here. Okay. Then, is it 1, 2, 3? For I. So length is going to be the number of elements in the list. So 1, 2, 3, 4. And then range goes from 0 to the value which is passed into it but isn't included. So that is 0 to 3, right? 0, 1, 2, 3. So yeah, it should have all of the rooms. Okay, so then I come in here. Keys is not empty, so I'm gonna come in here. Keys contains the value 1. Okay. And then key equals keys.pop. I'm guessing that that function returns what I'm expecting, which would be 1. So now 1 is here, and keys is now empty. All right, so now if key in not visited, which it should because it's 0, 0, 1, 2, 3. Okay. So then what do? I come in here, and now I remove 1. So now it's 0. Oh, wait. Hold on. 0 is still in this list, even though I visited 0. So I should do not visited dot remove 0, like this. I don't know if it's right, but we're gonna try it. Not visited, remove 0. Okay, go. Go, go, go. Oh, oof. Okay. So that wasn't it. So I remove 0. Okay. Then keys.append. And what am I removing? Or what am I appending? I am appending the values inside that specific room. So that's going to be this 2. So now keys has 2 in it. Okay. Then I come up here. Keys contains a value. It's 2. I take that. I pop it. Now key is 2 and keys is 0. So now 2 is not visited. So I remove 2. So now we have this is removed, and this is removed. Okay. Then I append the value in room 2, which is now 3. Then I come up here, I pop 3, so now keys is 0. And key is 2, right? Yeah. So now I remove 2 from not visited. So now I have 0, 1, and 2 all removed from not visited. And only room 3 remains in not visited. Then I append all the values in room 2, which is 3, or all the keys in room 2, which the only key in room 2 is 3. So then now keys contains 3, the value 3. So I come here, I pop out, keys is now empty. Key contains the value 3. 3 is still in not visited, so I do come here. I get 3 out of not visited, so now not visited, there's nothing in not visited. It's an empty list, okay? And then I append the values inside of room 3, which there are none. So keys is now still empty. Then I come back up here. This does not trigger. So then I come here and I return. So visited is empty. So it's 0. Then I apply the not, which is 1. And I return that. So it's true. I should return true. I think because I was able to talk this through, I walked through a test case, I think that my algorithm is correct, but I'm suspecting that there's some funny business going on with the function calls, or not function calls, but the operations, like remove and pop, and I feel like there's something funny going on here. So I am going to use print. So print, and then what do I want? let's see. Keys. Keys. I forget. I think it's like this. Format and then keys. Like that. Okay. Just returns an empty list. Still an empty list. Oh, because I just popped it. Yeah, that makes sense. Okay. So keys contains 1. Yeah. Print key, the singular, is now going to be format of key. Okay. Is a list of the value 1. Okay, so key. Is it because this is a list? So I don't want to append a list. I want to append the actual values within the list to the keys. Are we guaranteed that there's going to be at least one room? No, we're not. So we do need to figure that edge case out. So if not rooms, return true. Probably. Because you are able to visit all the rooms. Okay. So now at this point I'm guaranteed to have at least one room. So can I just go like this? So the double indexed. Okay. Not visited here. Okay, so maybe here I need to iterate through the value or through all of the values in the list of the or each room contains a list, and I need to iterate through the values in that list. So values equals and then rooms and key. So this is going to return a list to me of all the values or all the keys which are in that room. And then what I need to do is for val in values, iterate through each of the values in that array or list. Then I need to append keys, and I need to put in val like that. There we go. So I think my logic was correct. I was having a problem with the fact that I was indexing the 0th one, or the 0th element, which is this. Not 1, but the list which contains 1 in it. And then, like here, I was appending a list with 1, 3, and then I was saying if 1, 3 is in not visited. So, of course, 1, 3 is not going to be in not visited. I need to ask is 1, which means is room 1 in not visited? Is room 3 in not visited? Okay, so let's submit this. Let's actually take away these print statements and then try submitting it, and then after that we will apply some optimizations. So it's all the print statements. Okay. Darn. Outside the bounds of the array. I thought at this point we guaranteed. Maybe this means, oh, if room 0 has no elements. So what I'm thinking is, oh, it even says where it stopped. No, it's correct. Room 0 has no elements. Okay, so that's what I was thinking caused this error, because I'm guaranteed to have at least one room because of this statement. So if all the rooms there are no rooms, then that statement will hit and it just returns. So if I reached this location in the code, that means that I have at least one room. So I knew that this index was not the problem. So it must have been this index, which meant that room 0, because room 0 is guaranteed to exist, has no elements. So room 0 is empty. So what do I do in that case? I know the very unsophisticated way of going about it. Should I just do the unsophisticated way? If not rooms of 0. So I'm guaranteed that there is a room 0, but then I'm going to access that room 0 and get its value. And if it is empty, so in this case, I get room 0, and room 0, its value is an empty list, and so then it's going to trigger this, so it's going to hit. Now, I can process with that information. So room 0 has no values in it. Therefore, I want to say length equals rooms length of rooms. So now, if length is greater than 1, return false. Else, return true. So the idea behind this is, what I'm saying is, okay, so if we get an empty room, or if room 0, which is the only unlocked room that we have, if that contains no keys, then there's two options. Number 1, room 0 is the only room that exists. Therefore, yes, we can visit all rooms because only room 0 exists. Second option, room 0 has no keys and there are other rooms. In the case where there is other rooms, we can't visit them, and therefore we just return false. So that's what I'm doing here. Let's see if this satisfies. Darn. Why? That's unfortunate. I wish I had some coffee, but I got off work. It's almost 10 o'clock. I probably don't want to drink coffee or else I won't be able to go to sleep and I'll have a pretty bad day tomorrow. So, not drinking coffee, but man, that would help in this case. So why did this fail? Why did this fail? Hmm. So, uh, I'm not seeing anything obvious. I've already walked through my logic, and I think my logic was correct. And I went and I verified that each of the calls are working. So, in that case, I don't think it's a problem with like syntax or uh, indexing. This points back to a problem with my algorithm because if it was a problem with like indexing, then I wouldn't pass 66 out of 70. This is more indicative of a algorithm that is missing an edge case. And there must be something wrong in the way that I'm going about this. So let me just quickly go through. Okay, so 2 and 3 are in my list. Then I visit 2. So 2 is in my list. Okay. Then I go back up and I get. Wait, no, sorry. I visit this one. So 2 is in my list. Okay. So now I get 1 and 3. Okay, so I have this 3. So 0. I'm all messed up. Sorry. I come here. I get 2 and 3. Good. Then I come here. Then I get 2. But then when I come back up, I get 3. Now this is 3. So I have 2, 1, and 3. I go back to 2. Or I look at this value 2. I say I've already visited 2, so I don't add it again. And then I go to 1 and I take out nothing. And then I visit 3 and then I visited all the rooms. So I pop 3 and now there's nothing in keys and then I return and I should have nothing in visited or not visited. A lot of dust. Move that down. There we go. So, because nothing is obviously jumping out at me, I probably will just have to go take it to Copilot and do an autopsy. So, the result of this video is I was unable to solve this question. I will now enter the portion of the video where I try to understand what I did wrong, how I can improve, the different data structures that I should have used, the algorithm that I I missed, right? So kind of investigating what went wrong, how I can improve. So yeah. Okay. This is from the last video that we did. Now paste this in. Okay, verify that I'm a human, yep. And then give it my code and ask what I did wrong. What did I do wrong? Is it thinking or is it like stuck? Here, okay. It looks like you're very close, but there are a few adjustments needed. Here are some suggestions to improve your solution. Initial key. Your code starts by adding only the first key from room 0, but there might be multiple keys in... Oh. Okay. That makes sense. Your edge case handling for empty lists is correct, but could be simplified. Okay, so this is an improvement that I can make. This is a structural a problem. This, I think, is probably what's causing my error, because I don't add all of the keys which are in room 0. I only add the first element, or the first key that I find in room 0. Okay, checking all rooms. Ensure that your code uh, ensure that your loop continues checking all keys until no more keys in the room can be visited. Okay, so before looking at this revised, I'm going to fix the problem here. So what I'm going to do is like this. Okay. So I'm going to add all of the keys. So vals equals rooms dot rooms of 0. So now for val in vals keys dot append val, then I can get rid of this. So what I'm doing is I am looking at room 0, and that's a list. It's a list like this, 1 and 3. Okay? Then what I do, so now vals has 1 and 3. I iterate through each of the values in the list and append that to keys. And I believe this would mean I don't need this code anymore. Let me try that. I believe this would mean I don't need this, because in this implementation, if room 0 contains an empty list, I am going to come here. I'm going to say for val in vals, which is nothing, so it's already gone. So it's not going to enter this loop. Then it's going to come here, and keys is going to be empty, and it's going to come here, and visited is still going to be populated. And then do I need to pop the room of 0? Okay, good. I already did that. So submit. There we go. Okay, that was the problem. It was... Now, hold on. This is 14 milliseconds, so my code is definitely not optimal. We're going to go through and try to optimize things, but we got the main idea. Cool. So now let's try to optimize it. I'm guessing that it's going to be something to do with this, like I can make that into a hash or a dictionary, something like that. So let's see how it was saying I can optimize it. So, getting a phone call. Come on. There we go. So let's try to optimize it. Okay, they are using a set, which means sets are mutable. Good to know. Okay. Visited. Add. So I really need to just like I need to go through and learn each of those, like set versus list versus tuple versus all of these. I keep saying that I'm going to do that. I just don't. I want to make an excuse that I don't have time, but you always have time in your day. You can always find time to do important things. So I want to make that excuse, but I can't. So I mean, let's do it right now. So let's see. So I have visited, which is a set. So what are the methods available to me in a set? It's going to be add, apparently, add keys.extend. Okay, I'm guessing based off the implementation that extend just takes all of the elements within a list and adds it. Okay, length keys, which is keys is a list. Okay. So visited is the only thing that is I'm trying to figure out how this is more optimal. Okay. Use a set visited to keep track of visited rooms. Add keys from each newly visited room. How is your implementation more efficient? Proves efficiency and clarity by... Okay, well, I'm not worried about clarity right now. Why efficiency? By addressing a couple of key aspects. Initial key handling. Okay, that we fixed that problem. Using sets. That's kind of what I want to know. I use a set to track visited room, which provides O of 1 average time complexity. Okay, for membership check, this is the most efficient. Okay, so I guess just sets are able to be indexed quicker. Okay, so let's change this. So I want not visited. I'm gonna use the same kind of idea. So not visited is going to be a set. I think that's the way that it did it. And then can I go like this? I want to not have this, but can I go not visited dot add, and then what do I want to add? I want to add I, and then not visited dot what's the method available to me for remove? Okay, are the available available to me for Python sets. And this is what I mean I need to just get better at, because I always forget, like, okay, I know how to declare the set and the dictionary and the lists and all of that, right? Like, I know how, but what are the actual methods available to me for each of those? I also need to just create like a cheat sheet or something that I can keep track of all these things. So we have add, we have remove. Okay, so that's actually all I care about. I just wanted to see if we have, oh, there's a lot. Okay, I just wanted to see that we do have remove. Discard, okay. And remove. Okay. And then if this is empty, not valid. Here's remove again, and then this. If you get an empty set, I'm guessing that this will return the same what I'm expecting as well, which would be like if it's empty, it returns false. Darn. Okay. This. And then I just want to append. Okay. Let's see. See if it. Okay, there we go. So that was the problem. It was I needed to use a set in order to have an or a big O of 1 lookup instead of O of n, which is what I was initially talking about with optimizations at the very beginning of the problem. So that was this one right here. So yeah, anyways, I don't know if I'm trying to figure out if I should classify this as a success or a failure. I think we already declared that it was that we were defeated by this problem, or I was defeated by this problem. But when we looked at Copilot, it wasn't a problem with the algorithm. It was just I made a silly mistake with the indexing the first, this one, indexing the first element in the rooms and not all of the elements. So, okay. But anyways, thank you guys so much for watching this video. If you liked it, please subscribe. My name is Timothy Lee Grant, and I will see you in the next video trying to do more LeetCode, more LeetCode, more LeetCode. Anyways, have a wonderful day, and I will see you tomorrow. Every day doing LeetCode. No breaks, no stops, no excuses.